Hi guys, my name is Yash and in this particular video I'll be talking about your Heartzbleed attack, which is also called your frequency side channel attack. So recently a security vulnerability in our modern Intel and AMD processors have been discovered, which can let remote attackers steal your encryption keys via this particular attack, right? So before moving or talking about this particular attack, let's discuss what is a side channel attack first, right? So a side channel attack is your security exploit that will attempt to extract your secrets from a system or a chip. This can be achieved, right, by measuring or analyzing your physical parameters like your current supply, your execution time, or we can say your electromagnetic emission, right? These are your few physical parameters through which we can analyze and measure. Now this particular attack will pose a serious threat to the modules which are present in our system whose prime function is to integrate your cryptographic system. Okay, now let's see. Next question comes, how does a side channel attack will work? Okay, next very important question will be, how will this attack work? Right. So whenever a attacker is doing a side channel attack, he will not target a program or the code of that particular program directly. Rather, what he will do, he will attempt to gather information or he will try to influence the program execution of a system by measuring or exploiting indirect effects of the system or that system's hardware. Okay, so in simple terms we can say that your side channel attack will break your cryptography by exploiting information inadvertently leaked by a particular system. So real-time example of this particular thing is your VANAC freaking attack. VANAC freaking attack, which is also called your tempest, which is also called as tempest. Tempest is your transition electromagnetic pulse emanation standard, right? So in this particular attack, what will happen? This attack will monitor the electromagnetic field radiation emitted by our computer screen to view information before it is encrypted. Okay, so overall understanding, we can say that we will try to break our cryptographic modules. Okay, this is our overall understanding for this particular attack. Now there are few vectors, right? There are few side channel attack vectors which we should know of, right? So few of your side channel attack vectors are, right? First is your timing attack. First is your timing attack. Now here what we will do, we will analyze the time of a system which spends executing your cryptographic algorithm. Second is your electromagnetic attack, your EM attack. So here what we will do, we will measure and perform a signal analysis on the electromagnetic radiation emitted by our system. Third is your SPA, simple power analysis. Simple power analysis. Here what we will do, we will directly observe the power and your EM variations, your electromagnetic variations of a cryptographic system during its operation. Fourth is your DPA, differential power analysis. Here what we will do, we will obtain and analyze the detailed statistical measurements across multiple operations in a particular system. And last is your template attack. Last one, your fifth one is your template attack. Here we will try to recover your cryptographic keys by exploiting an identical template device and comparing the side channel data of both the devices. Okay, so these are few of the side channel attack vectors through which we can measure and analyze your physical parameters. Now coming back to your Heartzbleed attack. Okay, in the starting we have discussed that this attack is exploiting a security vulnerability which is present in your Intel and AMD processors, which can allow your remote attackers to steal encryption keys from your system. Okay, this thing has been discovered. Like, I'm talking a bit more detailed about this particular attack. This particular Heartzbleed, right? The name which they have given. This thing has been discovered by your researchers from University of Texas, Universities of Illinois Urbana-Champaign, and your University of Washington. Okay, so it's a new computer hack that can take advantage of your power saving feature common to our modern computers chips in order to steal sensitive data. Okay, now how they have discovered this particular thing, what they did, they demonstrated that how a attacker can use your novel chosen cipher text attack against your SIKE. Okay, against your SIKE to perform a full encryption via a remote time. Now, first of all, what is SIKE? SIKE is your super singular isogeny key encryption. Super singular isogeny key encapsulation. Okay, so basically it's a key encapsulation mechanism. Now again, a question will come that what is a key encapsulation mechanism? So a key encapsulation mechanism is a protocol used to securely exchange a symmetric key using your asymmetric cryptography, which is also your public key, cryptography. Now, most chips use a technique called dynamic voltage and frequency scaling. Okay, most of our chips use a technique called dynamic voltage and frequency scaling, which is also called your CPU throttling, which is also called your CPU throttling. Okay, which is used to increase or reduce the speed with which our chip carry out instructions to our machine. So ramping the power of the CPU up and down to match demand makes them more efficient, right? Because of this particular CPU throttling. Now there are few questions again which we can use again this particular attack. One of them is there a assigned CV for this Heartzbleed, right? Is there a assigned CVE? So both your AMD and Intel have given a separate independent advisories with respect to this particular finding. Okay, so for your Intel, okay, for your Intel, your CVE ID is your CVE 2022 2022 24436, and for your AMD, your CVE ID is your CVE 2022 23823 23823. Okay, so these are the CVE which have been given by your Intel and AMD with respect to finding of your Hertzbleed attack. Still, no patches have been made available by both the organizations. Okay, we don't have any patch for this particular vulnerability. Okay, now since patches are not available, but some countermeasures have been provided by your AMD and your Intel. Okay, so if I talk about the countermeasures which have been given by your AMD, so we can do your masking. Okay, we can do your masking. We can do your hiding or key rotation or key rotation on your software code of algorithm. This is the countermeasure which is given by your AMD. Okay, this is given by your AMD. Now Intel has said that they do not believe this attack can be done practically outside the lab environment. Okay, but they further recommend that cryptographic developers follow its guideline to harden their libraries and application against frequency throttling information disclosure. Okay, this thing has been stated by your Intel. I will add some reference links also right in the description or in the article through which you can read all the details which have been given by your Intel and your AMD. Now since we are talking about mitigation and all, most of the people will think whether this particular vulnerability, okay, or this particular Heartzbleed is a bug or not. Okay, so next question comes in our mind with respect to this particular part, that is your Heartzbleed? A bug. Okay. So the answer is no. The root cause of this particular attack is dynamic frequency scaling, which is a feature of your modern processors used to reduce power consumption and to ensure that the system stays below power and thermal limits which have been set for that particular system. Okay, so no, this particular Hertz plate is not a bluff. Okay, it's not a bluff. Now, again, next question will be, and our final question will be: is there a workaround? Is there a workaround with respect to this particular purge plate? So, as suggested by your researchers who have discovered this particular vulnerability, they have said technically yes, there is a workaround for this, but one of the disadvantage of that is it will reduce our system wise performance. Okay, it will impact our system performance. Now, in our Intel, we have a feature called Turbo Boost. Okay, and AMD will call it your Turbo Core or your Precision Boost. Okay, so if we disable your frequency boost through your BIOS or at a runtime via your frequency scaling driver, we can work around with this particular Heartzbleed. Okay, because in their experiment, when they disabled the frequency boost, the frequency stayed fixed at the base frequency during their workload execution, preventing leakage via your Hertz bleed. Okay, but again, this is not a recommended mitigation strategy because it will impact your system performance. Okay, this is what the researchers have stated for this particular attack. So we can say yes, there is a workaround, but that is not recommended by your Intel or your AMD.